Hello and welcome to my 5th YouTube tutorial on processing. Today we're going to be doing some 3D work in processing. So I'm going to start up a new processing sketch and I'm just going to go through it with you. There's two types of 3D renderers you can use. If we set up a size, let's put it at 200 by 200. Now usually we leave it like this and it will still make the box right. But for 3D you need to add one other difference here. You add another variable here, and that is your 3D renderer. We're going to use OpenGL today, but you can also use P3D and more recently OpenGL2. But that is, let's see if we got it here. It's not in this version, but you can get it in the latest version of processing. So yeah, we're going to be using OpenGL today. There's slight differences between the different renderers. If I show you the reference for OpenGL, can I do that? No, I can't. Let's just quickly go to the forums and find it then. Hang on. There you go. And here's its quick description. OpenGL is a cross-platform graphics interface for 3D and 2D graphics. It allows processing programs to utilize the speed of an OpenGL accelerated graphics card. So basically with OpenGL it will use the power from your graphics card basically to render stuff, as opposed to P3D, which doesn't do that. So yeah, it tells you everything here about it. It's got a really basic example here, which funnily enough is kind of similar to what we're going to be doing today, except we're not going to be using rectangles, we're going to be using cube. So I'll just come out of this now, but that's the reference here. And you'll also want to go to libraries as well, because it's in the libraries section where you can find a bunch of other useful libraries which we'll go through in later on tutorials as well. Okay, so we've set up our size at 200 by 200 and we specified our 3D renderer, which is OpenGL, and I'll just say that OpenGL allows us to play with 3D things. There we go. So what I should probably do is stick that in void setup as well. And I'm going to specify void draw too, because we're going to be using that in a minute. Okay, so and the other thing we're going to put in the setup is no stroke and smooth. I'm not sure we need smooth for 3D, but I'll put it in there anyway. We're going to set up another variable to increment stuff for us. That's something you'll find you'll end up having to do with nearly every sketch you make that's animated. And yeah, and let's import OpenGL again. You don't have to type this out, you can just go to sketch, import and then OpenGL, but I've just typed it out. Okay, so we've got our setup ready, so it will, oops, no capital there we go, so it will load up our screen now. Okay, so let's go into draw and start putting some things in. We're going to put our background to 0, oops, and we'll just start off by incrementing. We haven't used it for anything yet, but I'm going to put that in there anyway, and we will use it for something soon. I'm going to put in push matrix and we're going to start drawing a cube. So basically I have to translate first of all, and I'm translating it to width divided by 2 and height divided by 2, and the reason for that is I want it to be in the middle. So yeah, that's the way I'm gonna do it. And now what I'm going to do is put in something called box, which is our cube basically. That's the keyword box. If I show you that in the reference, oh, there we go. It's quite a simple example of a rotating box. So it rotates on its y-axis, and you can draw boxes in different ways. So you can specify either your width and height and thickness. That's how deep it goes into the z-axis. So that's its x-axis length, its y-axis length, and its z-axis length. So if I open Photoshop and draw that for you quickly, so you sort of understand it. It's got it down here as well, width, height, and depth. Let's just wait for that. Go to File, New, okay. So it's got the three planes. It's got its y-axis, it's got its z-axis, and it's got its x-axis. So the x-axis is actually going backwards. So if I was to turn this into a cube, you'll see what I mean. See that? Yeah, so that's our x-axis, so y-axis, z-axis. Yeah. Does that make sense? Okay. So the three variables we got x, y, and z here for our box method. Okay. So if I just show you that now, we've got x, which is 150, our y, which is 150, and we want it to be a cube, so I'm going to put 150 for z as well. So it kind of works a bit like fill. You know, like sometimes we get lazy with film, we just want to fill it black, or we just want to fill it white. When you put that 0, what it really means is you're putting 3 zeros. Or when you put the 255 for white, what it really means is you're putting 3 255s, all representing the red, green and blue values. It's a similar concept with box. If I just put 150 here, it's saying set x, y and z to 150, whereas if I specify each one individually, it's saying set x to 150, y to 150 and then z to 150. So what I can actually do is change that to 100, for example, and it will no longer be an equal-sided cube. So I hope I can show you that now. Nope. Oh, because I haven't popped matrix. Let me just do that. The size is way too small for a box that big. What we're doing? It's about 600 by 600, and there we go. We got that. So it's not rotating at the moment. All you can see is that it's a rectangle, but that's because you're facing it from kind of like a bird's eye view, so you can't really see the rest of the shape. So what we're going to do now is I'm going to make it so you can see that using this increment value that we put in. You can use a function called rotate x. I think that's it, yeah, rotate x, and that should rotate on its x-axis. Let's try rotate y. So I put rotate x and rotate y, and now I'm gonna change it. I'm just gonna change it back to 150, so we've got a cube again. I'm gonna put in some lights. Take off smooth and see if that's affecting it. Or do you know what I'm doing? Oh, that's silly of me. I'm rotating after the box, and that's what's done it. Yeah, there we go. So now we've got a really fast spinning cube. Sorry about that. So what I'm going to do, now that we've got this fast spinning cube, do you know why it's caused that? So basically when we push matrix and pop matrix, it's overlaying an array on top of our current coordinate system. So here's our coordinate system here. It's overlaying another coordinate system on top of that, just for the cube, because I'm only drawing the cube within here. So it translates the coordinate system, width divided by 2 and height divided by 2, therefore moving it here, and then it will draw our cube for us. But the reason why the rotate x and y wasn't working is because after I pop matrix, it deletes that array again, and we won't see that rotation. So we need to draw the rotation before drawing the box, and then we can see it. So now that we've got this rotating, what I'm going to do is just change the increment to 0.1, which means it won't work because it needs which means it won't work because it needs to be a float, or it shouldn't work. If I go to let's change that, float equals 1. No, let's do 0.0. Let's put it to 0.9. Doesn't matter. There you go. It's going a lot slower. So basically, what I've done, I've changed the increment variable to a float, which means there's a floating point number. What I've done here is now said inc plus equals 0.1, and it's a very quick way to scale down values that are changing. Or if you wanted to, you could keep it as an integer, and then say +1, so it will go fast again. But you just do rotate inc divided by 10, for example, and then it will rotate nice and slowly again. But obviously it doesn't go as smoothly, so it's probably best to keep it as a float there. Division doesn't seem to work very well in processing, so take these out, and we'll change that back to 0.1, and you can see it's going around slowly again. Okay, so how is this working? Rotate X will basically rotate the rotate on its x-axis by an increment you choose. And the increment we've chosen is 0.1. So I'll show you that. Because it's like a shish kebab basically, spinning on its x-axis here. And if I comment out this, and then uncomment this, it'll be the other way around. And this one's like a doner kebab, rotating on its y-axis. Beautiful. Okay. So that's pretty much the basics for drawing in 3D. And what we can actually do, we've got rotate X and Y. Maybe we could do rotate mouse X and rotate mouse Y, rotate X mouse X and rotate Y mouse Y. Also, it can go really fast because we're moving our mouse around in it. We'll do that. But what we can do is scale it down again. So we can say mouse X divided by 10. Let's do times 0.1 actually. Mouse X times 0.1. Mouse Y times 0.1. We'll see how that goes. It's a little bit smoother now, you see. And we can really see what's happening now. Maybe 0.01 is a better variable. There we go. So now it's a lot smoother. So yeah, just have a play around with that. This is probably one of the most fun parts of processing, how you can mess about with this as well. And where we got this translate as well, maybe we can use this, so translate mouse X and translate mouse Y. And what we should get is the cube following us around. Like that. See that? Pretty cool, right? So a cool Android app, for example, would be something like you'd attach this to the accelerometer instead. So the accelerometer directly affects the position of it. And maybe if we have some sort of boundaries here, so when it hits the wall it stops. It'll be a really fun sort of get the dice in the hole sort of game. And it would be really easy to make as well. Now that's an idea, isn't it? That would be quite fun. Maybe I'll do an Android tutorial in processing, because it's quite easy too. It's not too hard. So if you've got an Android phone, if you just put in the comment of this video if you think that would be a fun idea for me to do an Android tutorial on processing, where we make some sort of game where a cube goes down in a hole. That would be good fun. But yeah, anyway, that's pretty much it for this tutorial. But what I'll do is I'll comment all of this and explain it one more time before I finish off the tutorial, because it's been quite a short one. So, no stroke is self-explanatory. I'll just find it in a reference just to show you. So, disables drawing the stroke outline. If both no stroke and no fill are called, nothing will be drawn on the screen. So remember, we've done no stroke before. Or I think we have anyway. I think we changed the stroke colour, where we made it look like there was no stroke. But what no stroke does is, so on all objects in processing, you should have an outline. On all shapes anyway, you'll have an outline, and that's what the stroke is. And by calling no stroke, it takes away that outline. You won't be able to see it. And no fill makes it so that there isn't a fill colour, so it becomes see-through. So if I was to call no fill instead of no stroke here, let's just go to no fill, and then I'll put in a stroke colour as well. Let's put stroke 255. Oh, what have I done? Oh, no fill. Yeah, there we go. There we go. You see we've got a cube going around like this now, because we've kind of reversed it basically. Whereas if I take off no fill and then put on no stroke, you'll see again it's gone back to that. It's pretty cool stuff, right? Yeah, look at that. Okay, so I'm gonna upload this tutorial to the usual place for you to download as well, and hopefully this will have helped you. But like I said, I'll quickly write some notes in these in the comment I'll write some comments even. So no stroke takes away the lines around the shape. There we go. It can be 2D or 3D. 2D shapes or 3D shapes. And then we've got our float again. This is a float set up to change the rotation. Oh. Designed for incrementation. And we got a background. Set the background color to black. Our lights. Put some lighting on our object. I don't think I really explained the lights I put in actually. I'll just put in to make it look a little bit better. But if you see, it's got shadows. Whereas if I took out lights, so if I take them out, if I just comment out lights, and now show you it, you see it just doesn't look very good. But if I put back in lights, can you see the difference? You can actually see all the shadows on it now. Pretty cool stuff, right? If you find reference on lights as well, finding reference on lights, there's a whole load of different ways to draw the lights. So you can, what you can actually do, I'm not sure it's actually here, yeah, at the bottom you've got ambient lights, directional lights, point lights, spot lights, or well, you don't want no lights, you want all of these. These four are quite important. You can do some really fun stuff with that in 3D, and it might actually become quite useful if you make a game using it. Like you can make a detective game or something using that. It's quite nice. Increment by only 0.1 so that we move the block nicely. There we go. And push matrix. It creates a new matrix. Creates a new matrix, an array of numbers on top of the current coordinate system. Uses that array of numbers to change the position of the coordinate system when requested. and we've got pop matrix, which deletes the array so that it doesn't affect any objects outside of the push and pop matrix. Creates a cube, or six-sided shape. Yeah. Rotates the y-axis, and again I want to state like a kebab. Rotates the x-axis like a kebab, and obviously when these two are called together, when these two functions are called together, it's going to rotate it, taking both of them into consideration. So like before in one of my first tutorials where we had the rectangle going down the screen, I think I can probably show you it actually. Hurry up. There we go. Okay, so this one here. This one here where we've got the rectangle going down the screen like that, right? It's a similar concept to that. So we're saying x++ and y++. So it goes diagonally. So if we run this again, you'll see when I'm moving it, it's not turning like a shish kebab anymore because we're calling rotate x and rotate y. So it's going diagonally. It's adding 0.1, I should say, to each of them whenever I'm moving my mouse. Pretty cool, eh? I think I've explained everything actually, haven't I? Apart from this translate. So I'll explain this. Translate the position of the cube just for the cube. Because of the push and pop matrix. And oh yeah, cubes are drawn from the center as well. I forgot to mention that. And our stroke makes the stroke color white, and I showed you that a minute ago. So anyway, hopefully this tutorial has helped you, and I'll upload this simple code online. Oh yeah, and this is called a library, by the way, if I didn't mention that. Processing.opengl. Import the library. Import the OpenGL library. That's it. And thanks for watching, guys. I'd go and check out the processing.org tutorials as well. See you later.